Hello everybody, so today we're going to be talking about how to make light. And the way we make light is through electricity and using light bulbs. I want to talk to you the difference in each light bulb, in the energy in versus the energy out, along with what's inside these light bulbs that we use. So the three light bulbs that we use today are the incandescent light bulb, which you probably have in your house. It's very common. The next common one is fluorescent. Those are the ones that you probably see at your workplace, your school, and those are the ones that are the long bars, but they're also the ones with the curly cube. It's the same thing. And then the last one is the LED. You might see them in a little bulb, in like your phone screen actually being made out of them, or they might be in a bulb similar to what looks like an incandescent. So, to get started, let's talk about energy. As you can see up here, I have this bar. Camera could come up here. So I have this bar, I have it labeled in, FLIR, and LED. Those are the different light bulbs. And as you can see, I'm measuring the wattage that's going into each bulb. As you can see, the LED is significantly less than the rest. And that shows that how much more efficient an LED is compared to the other two. And as you can see, the incandescent wastes the most energy. And that's watts. And you can measure that either in an output reader or a AC motor generator. Then over here, and where we're going with the lights, is we're starting to melt chocolate with the lights. As you can see, I have it about 2 to 3 inches away from the center of the light. Incandescent's a little far away, it should be a little closer. What we're doing is we're showing the heat waste that comes off one of these lights. Your incandescent light bulb is the most important one here because it's the one that wastes the most amount of heat. As you can see, I have a timer going for how long I've been doing this. As you can see, it's been since the start of the video, which was 2 minutes ago. So I have 12 bars of chocolate under each light that are 2 to 3 inches away from the center of the light. Along with that, this also works with the chocolate bunny. So any sort of something that will melt, it's a perfect way to show heat loss and with lights. So that's energy waste and energy taken in. So next would be what's inside of the lights. So what's inside in an incandescent light bulb? Well, for the experiment to show what's inside an incandescent light bulb, I can't show you here because we're not allowed to have a lighter in school. It's pretty much similar to fire, where you're heating and lighting something up through heat, and it's giving off energy and light through that. That's how your incandescent works, is you're applying a voltage to a piece of metal, metal heats up, and it lights up while it's heating up. So, next would be your incandescent bulb. Here I have an incandescent bar, and what happens is inside of this is... What? What did I say?
Incandescent.
I said incandescent? This is a fluorescent light bulb. Incandescents don't look like this. But inside of here are gases, some of which you'll learn about later. Like there's argon, all sorts of stuff in here. Anyway, so it's just a giant tube of gas that when it gets excited by an electric field, which is what comes out, or any type of energy that's electric or electronic. So a perfect case to show that is the electric field that comes off a nice plasma ball here. Plus it's cool to show to the children because it looks cool and they'll think it's really awesome. So what happens is if we turn out the lights here, you can really start to see the plasma ball going. And what happens is when the electric field is applied to the fluorescent light bulb, without even being plugged in, this isn't plugged in, I'm holding it in my hand, you can see it starting to light up as it touches the plasma ball. And that's, as you can see, it's lighting up. And it can be far away from it too, as you can see. Or right on it. Right on it's where it gets a lot of its light. And it flashes. So that's pretty cool, right? Where the electrons are getting excited by the electric field, and they bounce around in here and make light. And then my last light to show you would be an LED light. LEDs, I want to stress to them, are kind of what I want to focus on here because they're what we should strive for. They're the most efficient light that we have. They use the less amount of energy, and they're just all around a great light, and you can actually achieve white light with LEDs, which is pretty cool. So, an LED is similar to a solar panel, which is another good talking point that you can talk about, because that's a growing field right now, is solar. So what happens is electrons, you don't have to go into this in depth with it, but so what happens is electrons move around and it jumps a gap in a p-n junction, which is way too complex for this. But pretty much what you need to understand is solar panels and LED lights, they have the same thing inside of them, except for a solar cell takes light and turns it into energy. That's pretty much the summed up version. An LED takes energy and turns it into light. So as you can see here, I have a little experiment showing solar cells. These are very small. They're about 1.5 volts each, and when you plug it into an LED, it's not glowing right now because there's not a lot of light in this room. Along with that, we're not outside. If we were outside right now, this thing would be glowing red so brightly. Anyway, so why don't we go back to our chocolate where it actually has started to melt. As you can see with the incandescent, it's already starting to get watery and bendy. Fluorescent, it's about the same. It's starting to get a little glassy. And LED is just, it's cool as a cucumber. That's what I have. So we're at 6 minutes now. It's melting. Last thing before I go is I have to show you the materials I used. Right, camera person?
Yep.
All right. So the materials I used. Let me just turn up the lights because it's dark. The Dickens in here. So what you need is the light bulbs that I had in the lamps, which is an LED light, a fluorescent light, and incandescent light bulb, which I think is spelled wrong. Yeah, no. I'm sorry if it's spelled wrong to any teachers who are watching this. My bad. I didn't do well in English. Anyway, along with that, you also need a way to measure power. Now, you can have an AC hand crank. I didn't have that here. I had an output reader. Either would work. With a hand crank, what you would do is you'd have the children crank it, and with the LED, it would light up really quickly, or then compared to the incandescent, it'd be really hard for them to turn it on. Maybe some of them might not even be able to get the incandescent bulb going because it takes so much power. Next, you'll need chocolate, as I had there for the energy, or the waste heat. You can do bars like I did. You can do bunnies. Bunnies are pretty cool because you can actually see them melt really cool, and that's pretty awesome. But yeah, bunnies are pretty hard to get when you're here in the month of May. Anyway, you'll need a plasma ball. That was the big spherical thing. You'll need small PV cells. You can find those. Either ask your tech teacher, like your shop teacher. They might have some. My shop teacher did. If not, physics teacher, or they're not too expensive to get, I believe. Just search around. Along with that, you'll need a breadboard and assorted wires that you can also get from your tech or physics teacher. So that's pretty much it. You also need a fluorescent bar light. That's what I had. You can just steal that from your lights. And then a small LED bulb, which you can also probably get from your physics teacher or your tech teacher. So that's it. Any questions? I can't answer them. So have a great day.